Welcome to this introduction to InstaMAT nPass graphs. An nPass graph allows you to take an atom, in InstaMAT an atom being a program run entirely on the GPU, and iterate it over and over again, providing the previous iteration's result as the input for the next iteration. This iterative functionality allows you to build complex procedural patterns and effects while harnessing the powers of the GPU. Today, we are going to walk through the creation of an nPass graph while explaining the basic concepts required and demonstrating a sample of its potential. What we'll be creating is a very basic scattering node with random translation and rotation. We'll also talk about concepts like variables, an image buffer, and what specifically an nPass graph needs in order to persist data for the next iteration. Without further ado, let's get started. Okay, so the first thing I'm going to do is I'm going to create a new nPass element graph, and I'm going to do that by going to the plus icon in the toolbar here. And this will bring up the new project dialog, and you can choose from all the different projects that you can work on. Let's choose the nPass element graph here. Upon creation, an nPass graph provides two functions, onExecuteAssignment and didExecuteAssignment. OnExecuteAssignment allows you to provide the nPass graph with information stored in its nPass local variables. These nPass local variables are only accessible from within the nPass graph itself. Using nPass local variables, you can store and process information accessible to other nodes within the nPass graph without that information being public. This way, the information is unavailable to the other nodes in the graph where your new nPass node resides. On the other hand, input parameters are public and can be accessed from the outside. Input properties are what you adjust using the graph object editor when changing the properties of a node. It's important to note that nPass local variables are different from regular local variables found in graphs such as the atom graph. You can tell the difference by noticing the nPass logo on the node itself. Upon the creation of our nPass node, we can automatically assign some information to the first iteration of our program. We can do this by attaching connections to this onExecuteAssignment function. The second function, didExecuteAssignment, is accessed every time a loop or iteration is completed. This is where we have the chance to update the value of our nPass graph's nPass local variables. We'll work with this function later on in the video. If we look at our current list of inputs and nPass local variables, we can see that we have two already, a passCount input and a passIndex nPass local variable. These two are linked together. Think of the passCount input as a way to tell the nPass graph how many times you'd like the program to loop and get its result. Think of it as the sample count parameter in the slope blur node. The slope blur node itself is an nPass graph, so when you increase the sample count, you're actually repeating the slope blur's program to smooth out its result. The passIndex nPass local variable is a way for our nPass graph to understand what iteration number we are currently on, allowing us to perform some logic with it. To access our inputs and nPass local variables in the graph, all we need to do is drag them from the graph object editor into the canvas. You can see that I've now dragged the passIndex nPass local variable into the canvas, and you can see that it's an nPass local variable with the logo assigned to the node itself. What I'd like to do is generate a set of random numbers for every iteration. We can do this with a random number node. I'm going to bring that in now by right-clicking in the canvas to bring up Quick Search and typing in random number, and then I'll hit enter. The random number node allows us to choose a minimum and maximum number, as well as a seed number to base it on. Let's use our passIndex variable to determine the seed of our random number. So what I'm going to do is connect the passIndex to the seed. Now I'd like to change the minimum and maximum numbers here. So I'm going to click on my random number, and then in the graph object editor, I'm going to change my minimum and maximum numbers to -1 and 1, respectively. This random number will determine the rotation of each image that we are scattering across our texture. In addition, I'm going to need two more random numbers for the x and y values determining the position of each scattered tile. So I'm going to create 2 more random number nodes. I'm going to right-click and choose random number. Another way to do this is to use Alt or Option and drag. And this will create a copy on our canvas. Then I'm going to branch a connection from our pass index variable here into the seed of both of these 2 new random number nodes. I also want to adjust the minimum and maximum values for these second and third random number nodes. So for both of them, I'm going to set it to -0.5 and +0.5. To add more randomness to these attributes, I'd like to change the local seed to each of these random number nodes. The local seed of a node can be found in the instance properties in the graph object editor. You can see that if I change the seed of each random number node to the same number, in this case 1, you can see that these 2 random number nodes are producing the same result. When we feed in a number to the separate seed input, the random number will use both the local seed and the inputted seed to create a unique value. It's important to note that when a new node is created in the canvas, whether it be through quick search, or through the graph library, or even through duplication by holding Alt and dragging, the local seed will automatically be set to a random number. Let's change the local seed of the first random number to be 100. I'm going to click on the pencil and type it in here. Now let's change the local seed of the second and third random numbers to be 200 and 300 respectively. To keep ourselves organized, let's create a comment encompassing everything we've done so far. To do that, I'm going to hold Shift and click and drag over all of these nodes, and then I'm going to hit Shift and then the C key. For the name, I'm going to call it Generate Random Values, and hit Enter. Next, let's bring in the node that we are going to provide all of our data for, the Transform node. This demonstrates how we can bring in many different kinds of nodes into our nPass graph. We aren't just limited to variables and mathematical functions. So I'm going to bring in a Transform node. I'll just right-click to bring up Quick Search and type in Transform. And what I'm going to do is I'm going to set the Transform node's sampling mode to Clamped Border to remove the automatic tiling. Next, we're going to need something to transform. Let's supply an image input that the user will be able to supply by creating a new graph input. I'm going to click on my graph to make sure that I have the graph object editor visible. You can also press Shift-1. Next, I'm going to go to the plus button and I'm going to choose Element Image Gray. Let's double click on this parameter name to change it, and I'm going to call it Image, and then hit Enter. Then I'm going to drag this new image input into the canvas. Right now, this image is set to default by applying a solid black color. However, to show us what we're doing as we work, let's use an image from the graph library. So I'm going to go over to the image parameter and click on the pencil icon. I'm going to choose this grayscale image of the InstaMAT logo. Now let's connect our image to the input of our transform node. Now let's add some more functionality to our node by utilizing our random numbers and creating some more inputs. What I'd like to do is adjust the rotation of each scattered shape, provide a rotation variance so that each tile will have a random rotation based on the range I give it, and be able to change the scale of all of our tiles. Let's tackle the scale first. You can see I've just made some room in my graph so that we can organize things a bit more clearly. First, I'm going to create a vector2 float input because scale requires an x and y value. The quickest way to do this is by using quick search by way of the transform node. But first, we need to expand the available input parameters of our transform node. We can do that with the Expand Parameters button on the node itself. I'm going to find the scale input, and I'm going to branch a connection off of it. I can then choose to expose scale as graph input. You can see how using quick search, we saved a couple of clicks instead of going to the inputs of our graph object editor. It also automatically sets the graph input to the correct type. In this case, the transform node is looking for a vector2 float value type, denoted by the light pink graph connection point. I'm going to set our scale input to default to 0.1 for both x and y. I can also access more properties about this scale input by clicking on it and going into the Graph Variable Editor, or Shift 2. You can see we have the minimums and maximums here. For the maximum x and y, I'm going to change this to 0.5. I'd also like to make it so that the x and y values stay the same whenever one of the two is changed by default. We can do this by clicking on the lock icon next to the values in the Graph Variable Editor. If I right-click on the Transform node and choose View Image Output, we can see what it's doing in the image viewer. I can also go to my Graph Object Editor and change the scale. You can see that the values are updating accordingly. Now, let's take advantage of our two random numbers and scale input to generate a random position for each of our scattered images. We need to convert these two random number nodes into a vector value type. To do that, let's use Quick Search again. I'm going to branch off a connection and let go to bring up Quick Search, and then I'm going to type in make. And you can see we have a bunch of options here. I know that I want to make a vector2, so I'm going to choose make vector2. Now all that we need to do is connect the other random number node. Now, if we try to connect our make vector2 to the translate input of our transform, as we change the pass count, the image only randomizes its position within a small area. Let's expand that area by dividing our vector2 for the translation by our scale graph input. Another way to add nodes is by right-clicking the connection point in the canvas to bring up Quick Search. I'm going to type in the divide key, and then you can see that it has vector2 divided by vector2 automatically. Now I just need to hit enter. Now I can take the scale input and connect it to the B input of our vector2 divided by vector2. If I go back and change the pass count, you can see that the area that the translation is occurring is much larger. We're going to take some similar steps towards setting and randomizing the rotation. I'm going to create a new graph input, and I'm going to want it to be a float, 32. I'm going to call it rotation, and then I'm going to drag it into the canvas. Notice how our rotation parameter is using a spin box control by default. Let's change it to a vector angular control. I'm going to click on the rotation parameter and then go into the Graph Variable Editor. You can see now I can choose the control type here from spin box and change it to vector angular. This brings up one of these angular controls here. Let's create another input called rotation variance that will tell our nPass graph how much it can randomly rotate each tile for each iteration. So I'll go back to the Graph Object Editor and create another float 32, and I'm going to call this rotation variance. I'm then going to click it and go back to the Graph Variable Editor to change it to a vector angular control. I also think that I want to start off with a little bit of rotation variance by default, so I'm going to change this value to 64. I can then drag this new input into the canvas as well. I'm going to make a little bit of room here, and I'd like to multiply the rotation variance variable by our leftover random number node here. So I'll branch off another connection from the rotation variance input, let go, and type in the star key to bring in a float times float node. Then I can take the result from our first random number here and plug it into the B input of the float times float. Now we can add our regular rotation value to this value so that no matter what the value is that we get, our tile will rotate by this amount every time. So I'll branch off a connection from the rotation input and type in plus, and then bring in the float plus float node. Now I can take the result of the float times float node and bring it into the B input of the float plus float. So in total, we multiplied our rotation variance input number by the random number generated here. We then added the rotation input to that result. Let's take that result and plug it into the rotate input of our transform node. Notice as I drag the pass count now, the rotation is randomized. I can also adjust the rotation parameter to assure that I'm going to get that rotation to start with. And that's all the logic we need for our transform node. Let's group this all together by creating another comment. Again, I'll hold Shift and drag to select all of these nodes, and then hit Shift-C to make a new comment. I'm going to call this comment, set up our random scatter transform. The last two things we need to do are create our image buffer and set the output of our new node. The image buffer is what will persist over each iteration, allowing our nPass graph to blend these scattered shapes on top of one another. Let's start by creating the buffer nPass local variable. We're making it an nPass local variable because we don't want the user to be able to access this buffer directly. So I'm going to go to the local variables tab here, hit plus, and I'm going to choose element image gray as the type. I'm going to double click to rename, and I'm going to call it buffer. Then I'm going to drag it into the canvas. What we need to do is we need to blend our buffer with the first iteration using a maximum blending mode. So I'm going to right click and bring in a blend node. I'm going to take the output from our transform and bring it into the foreground of our new blend. I'm then going to take the buffer nPass local variable and connect it to the background. Now I'm going to click on my blend to change its properties, and I'm going to set it to maximum. In order to get this to work, we have to assign the output of the blend to be stored in the buffer nPass local variable every time the graph executes. This is where the didExecute assignment function comes in handy. I'm going to bring this over a little bit, and let's assign the output of the blend and drag it to the buffer in the didExecute assignment function. Now, every time the graph iterates, the buffer will be set with the blend applied with the maximum blending mode. If I right-click the blend node and choose View Image Output to see what's going on in our image viewer, you can see what's going on as I increase the pass count. Finally, let's create a graph output so that our result can be retrieved and used by other nodes. Let's use Quick Search to drag a connection from our blend and create an output. You can see expose output as graph output appears. Before we test this out, I'm just going to assign a name to this nPass element graph. So I'm going to click on the graph and go up to name, and I'm just going to call this simple scatter. Now that I've saved everything, you can go ahead and hit plus to create a new element. I've done that here. Now let's drag our scatter node into the canvas, and you can see it appears like a normal node would. I can go ahead and change the pass count here. And to see the output in the viewport, you can either right-click like we've done before, or you can left-click on the output here. Let's find another image. So I'm going to go into my graph library, and perhaps this time I'm going to bring in the logo with the beveled edges. You can see that the new image is getting applied. I can change the rotation and also the rotation variance. I can also adjust the scale, and you can see that those parameters are locked together so that they're going to mirror each other and keep the same values. I can also adjust the local seed of this node and get an unlimited amount of variations. Thanks for watching this quick introduction to nPass graphs. While we've covered a bunch of concepts including graph inputs, nPass local variables, image buffers, value types, and mathematical expressions, there's a lot more to uncover. If you'd like to take this further, try taking what we've learned and create some variances for the luminance and scale of each tile. nPass graphs can be used to build complex systems ranging from particle simulations to mesh modifiers. While we used an image buffer in this example, the nPass element graph is not limited in the kind of data that can be persisted across the execution boundaries. This can include mesh data, strings, and more. Be sure to check out our future videos for more information, and we'll see you in the next video. If you enjoyed this video, drop us a comment below, and don't forget to subscribe. For the latest news about InstaMAT, please visit our website and follow us on Twitter. You can find all the links in the video description below. Thanks for tuning in, and we'll see you in the next one.